To tech Tide. Let's see today's problem, prime pairs with target sum. It says you are given an integer n, we say two integer x and y form a prime pair, so x and y should be primes, the summation should be n, x and y should lie within the range 1 to n. So that's our constraints. So in the first example we have n is equal to 10, 3 and 7 are prime, 3 and 7 summation is 10, 5 is prime, 5 and 5 are prime and its summation is 10, so x is equal to y. This is also valid scenario. The other would be like 7 comma 3, but it's already included in the shorter and larger pair, so we don't need a larger and shorter pair. For 2 we don't have any prime which is less than 2 and whose summation is 2, so that's why it's an empty array here. So looking at the question, it seems like we need to calculate how many primes we have, what all primes we have till that number n, and then we can iteratively calculate the difference starting from 1, and if it's a prime we can just add it to our list. Let's try that approach. So we'll have all the primes, so I'll create a helper function for that. We'll say find all primes, we'll say int 10, and then we'll say let's declare our primes captivate. We'll have here our primes are declared, our primes is equal to new boolean. Let's add it n plus 1 to get rid of that indexing, and then we'll say we'll fill this arrays dot fill. Initially everything was expected to be a prime, but we do know prime of 0 is false, 0 is not a prime number, and prime of 1 is also false. Then we can start. Okay, let's start with 2 I less than, we know till square root we can have a number to be divisible, so we'll iterate till that, and then we can say factor of all those 2's 3's will not be prime, they will be divisible by the corresponding number. So we can say, let's call that multiplication as out p multiply I. So if we can say primes of out will be false, we'll mark it as false, but we only, this can go out of bounds, so we can say if it is within my number range I can just add it, otherwise we can just break it off. So now we'll have this. Let's validate our implementation. So we'll have here println arrays dot to string, we'll pass our primes here, and then let's return, for the sake of compilation we'll just return collections dot empty list for now, and we better need to call that function so that we can have our sys out. Let's run it. So it's called collections, right? So we have 2 3 5 7 as our primes, and what we want. Okay, this is 1, this is 2, and till 2 we have just the 2. There's one more improvement that we can do, like if it's already a prime we don't need to capture it again. So if it's a prime, and then only we need to capture that value, otherwise we don't need to, because it would have been added from the second, third, or the multiplier. For example, I'm talking about 7, so we don't need to check all the multiples of 7, because 14, 21 all would have been already marked as false with 2 and 3. So let's just check if still valid. 2 3 5 7 we are valid. So now we can say for int I is equal to 1 I less than my n by 2 I plus plus. So here we can say it can be I plus 2, so that we don't end up into larger and smaller pairs. So we'll just stop at 5, right? So for this example, and then we can say, okay, let's just name it as per our question. So this is my x, and my y value will be the n minus x. If this is a prime value, if x and y both are primes, I can say just add it to my out list, right? So let's have a out list which will just say list of x comma y pairs. Then instead of returning this empty list, I can return my out list. We can declare it above is equal to new array list. So now we can just check if our functionality works. It looks like okay. Let's just run it till the bounds. So okay, it's accepted. We might want to get rid of this out to avoid adding the debug output. Let's hit submit. Yep, it beats 100%. Thank you. So yeah, that's the intuition behind it. We can find all the primes, and from that primes we can just capture the difference. If they are prime, we can add it to our list. It would be ascending order by default because we are starting from the shorter and larger pair and eliminating the larger and shorter pairs. So yeah, thank you.